Good afternoon. Am I audible, please? Can somebody confirm?
Yes, and your screen is visible.
Okay, thank you very much. Gentlemen and ladies, good afternoon to all of you, and thanks for joining our webinar. Capricorn Technologies and Autodesk. We are hosting this webinar on Fusion 360, which is our next gen cloud solution. Rather, it's getting very popular among major OEMs and industries across the globe. So coming about 90 minutes, we'll bring forth some details about the product, how is it being used, the functionalities, and also we'll take some of the queries. I request you to put your queries in the chat box. So during the process or end of the session, we will try to answer your queries. We have a technical session by Autodesk specialist. And a customer speak, Mr. Devesh Rai would be speaking about how he's benefiting from this beautiful software and how he's able to make an impact with his customers. So thank you very much again for your time. And we hope that this session would be useful to you. Coming back, my introduction very short. My name is VK Mishra. I represent Capricorn Technologies. And in this session, we have Mr. Vipul Agrawal from Autodesk, my colleague Prashant from Capricorn Technologies, and Mr. Devesh Rai. He's one of our customers. He is the managing director of Rita pads and printers. So thank you again. End of the session, we'll post a survey. Please give your feedback. It will help us, address your queries one-to-one and any kind of support what you need. You will also need this. You'll also will get these survey links through a mailer. Probably post this session, could be tomorrow. Please respond to that. We'll appreciate your feedback. 2 minutes on Capricorn Technologies. We are part of Schneider Electric Group, and we are 30 years into this business. We are a technology company. We support around 25,000 customers across India in multiple industries, extending from AEC construction industry to manufacturing to defense and so on and so forth. So welcome to the world of smart manufacturing. As the world is changing rapidly, the industries have to come together to be addressed, to be able to address the need of the market, the consumers. They are getting very, very demanding. And during this environment, especially, lockdowns and pandemic, it becomes very essential for us to innovate fast, change rapidly, and address the market requirements. So the solutions like Fusion 360, it helps you innovate faster, make more products, reduce your inefficiencies, reduce your wastages, and improve on the design, reduce cost, and so on and so forth. So introducing our customer speak, we'll have Mr. Devesh Rai. Just after my session, we will help him. He'll be, talking, sharing his experience. So he's is graduated from Germany, and he's the managing director of Rita Pads and Printing. From 30 years, they are leaders in the market, more than 50% of market share. And essentially, it's a very, very critical machines. They design over 50 machines have been designed till date, and the list goes on and on. And each of these machines, these are not high volume machines. They are specific to the customer. would mean that each machine needs to be redesigned with essence to quality, speed, and performance. Other than Mr. Roy, we have Vipul Agrawal, our technical specialist from Autodesk India. He'll be giving the technical session on the subject. And Prashant, he's a solution specialist from Capricorn Technologies. So jointly, we'll try to explain you about the product and how does it benefits your industry and whatever activities you are doing. And then on, we can also address you one-to-one. So let's start with a very tough, challenging task. What would you do if you are asked to design a Mars lander which has to travel beyond 300 million miles, is the lightest in design, is the strongest as much as possible, and absolutely zero chances of failure? That's one of the toughest tasks what anybody could get, and I'm sure they will spend sleepless nights. So what we need, certainly we need a lot of brains together and a very intelligent tool. So that's the project what we are talking about here. NASA Jet Propulsion Lab along with Autodesk. We designed this commendable job, and obviously we know that it succeeded. It succeeded beyond the performance. So that's the project where we work together along with NASA. So there's a small video on this.
We're trying to do something that's never been done before. Something that seemed impossible.
We are constantly trying to push our designs just a little bit further. I'm always saying, make it even better. Before I had Fusion 360, the question was, can I really make that? Now it's more like, what can't I make?
Now I have a simple way to solve really complicated problems.
Starting a project used to be so daunting. We'd spend days trying to make a prototype. I love how intuitive the software feels. It's like an extension of my brain.
Our team is really tight-knit, even though we have people all over the world. Fusion 360 keeps us connected.
I'm able to spend more time with the things that matter to me most, because I can get my work done anytime, anywhere. It's an amazing feeling to hold something you've brought from idea to reality.
With Fusion 360, I don't have to compromise between cost or quality.
I'm an engineer.
I'm a machinist.
I'm a designer, and I use Fusion 360.
Fusion 360. One product, unlimited possibilities.
So essentially, it's not only the NASA's. Probably we have a couple of more videos. End of the session, we'll run it through you. But it's not only the lander project. It's any project what we deal day in, day out has immense data from multiple sources. Sometimes there are intents, there are expressions. Then the exact data what we are looking for. That the team has to work through multiple tools, multiple CAD tools for different kind of objectives and deliverables. So and multiple technologies, especially manufacturing. Depending on what you manufacture, what the source code, and what's the input to the machines. So these are the challenges what we face day in and day out. And there is a tool which can probably help you address some of these requirements. So essentially, we are dealing with disconnected processes. While processes itself have achieved a level of efficiencies, but gap between two processes, the lag time, the accuracy of data passed is always a challenge. Communication breakdown within the organization, and it leads to missing deadlines, quality issues, and virtually, this is what the industry goes in day out. And we are looking at whole set of data, different departments, different domain, different objectives. So it's all data, data, and data. What we need to really sync bring it on the same platform so that it helps do a job which is integrated, where we are looking to integrate right from concept to manufacturing on one platform. It's more collaborative in-house and out-house. So the stakeholders of the company and vendor system, and also it's accessible from anywhere from a device, which will help you do the job much better, more efficient. The manufacturing landscape is changing very rapidly. The machines are being able to redesign. They are more intelligent machines. We have more HMIs with sensors. They can give us a lot of feedback, but then integrating them to the complete architecture of any organization takes its own task, because the inputs have to be really segregated to one common source, and then we can go on to IoT or Industry 4.0 standards. So here is a tool, Fusion 360, which is integrated, which is collaborative and accessible to multiple technologies. So gentlemen, here it is introducing you Fusion 360. The next we have our guest speaker, Mr. Devesh Rai. I'll request him to share his experience, how he's using the tool and he gets benefited. Post this, we'll have the technical sessions and other sessions. So Mr. Devesh Rai.
Thank you, Mishra ji. Hi, I'm Devesh. I am director at Rita Pad Printing Systems Limited. We are a manufacturer of pad printing machinery. We've been around, we sort of introduced pad printing to the country in the late 80s and the early 90s. So some of the attendees might be actually familiar with what is pad printing. It is as of today, it is the de facto technology that is used for printing on physical products. If you drive a car or a motorcycle, pretty much every panel, every button that you touch, every cable harness, every part of your vehicle will probably have some level of pad printing on it. If you're in the medical industry, you would see pad printing is pretty much the only technology, because of the level of accuracy that it provides, that you would use to print the gradations. So if you're using a syringe, the gradations on the syringe, which have to obviously be accurate, would be something that would have to be pad printed. Or if you were using any kind of medical device, an insulin pump, where you would set the level of insulin that you want to deliver to the diabetic patient, that is something that would have to be pad printed, because again, that is a critical task. The issue though with pad printing is you can have 50 or 100 different types of standard machines, but no two customers are going to want the same machine. Then that's a huge issue. because as a manufacturer of this machinery, you need to be really involved in the actual manufacturing process. Every machine is bespoke. So, for example, if one of our customers is Maruti, and Maruti has a certain type of dial gauge they want printed, their design is their own, its design is unique, and you make a machine which would be specifically tailored for printing their dials and their gauges, and you do fixturing for that. You make a machine with enough clearance, with all the dimensions have to be able to fit the unit onto your machine and for printing. And then you also have Honda, who's also our customer, and they would have something which is entirely different. They would want to print something instead of in one color, in 4 colors. They want to print a product which is completely different in size. So you have to do fixturing again, and you have to do, redesign large portions of the machine for printing for them. And then the same machine or the same model of the machine, you want to also be able to provide to, like I said, the medical industry. You want to use the same machine to print on, say, cryotubes, which is something that is used in manufacturing vaccines that are in huge demand today. So you want the machine to be the same, as well as you want to be able to quickly change it as fast as your customer demands, as fast as the market is changing. And the only tool that we have found so far which can help us change our machine, change our products, change our work, because it's not just changing the product itself, it's also changing the way you approach in many cases, is Fusion 360 so far. So with Fusion 360, we've had the benefit of being integrated. Our whole team can be on the same software. So whether our design engineer is working directly with the customer to ensure that the fixturing is correct, whether our machine manufacturing engineers are working to make sure that the machine would fit everything that the design engineer is working with the customer to ensure, or whether our shop floor engineer is able to make sure that we are able to produce the manufacturing G code correctly, to be able to make our various parts, because every part is going to be unique in this, whether you need to generate fresh G code to laser cut different panel or different plate for part, or whether you need to be able to mill out a different piece for fixturing. Fusion 360 is pretty much the only tool that we could use to integrate it from the bottom up into our workflow. And I mean, we traditionally used a lot of 2D CAD. We used to be based out of AutoCAD for mostly everything, and it took us some time to see if we could make the switch to Fusion, and it really paid off. It's something that it's allowed us to do stuff which we didn't think we could do before. For example, even right now, when the pandemic happened last year in 2020, a lot of us were forced to work from home because we were using Fusion and a tool which is connected, internet connected, which allows collaboration and allows us to stay at home and be safe in our own homes, and still be able to virtually communicate with our customers and actually do work which in the factory the manufacturing engineers, the shop floor engineers can actually live see the updates that, you have a plate, you've made 4 extra holes over here for mounting an additional bracket. they can see it live as you do it, and everyone is updated on the progress that's actually happening with your machine, with your project at that point of time. And yeah, it's been great. We've been one of the happy customers of Autodesk on this. That's pretty much it from my side. Mr. Ji, anything else?
No, perfect, Mr. Rai. Thanks for sharing your experience. And essentially, I think you said it very right that during the pandemic, when work from home, coming to office was almost barred. This is a tool, or such tools would help us to continue working on our existing projects and the new projects. So thank you very much. We appreciate your time. So
Thank you for having me.
thank you. And now introducing Vipul, our colleague from Autodesk, who would run through the technical presentation. He will talk about the features and functionalities of the tool. I'm sure you'll find it very interesting. So Vipul, over to you.
Thank you, Omkesh. Everybody can hear me?
Yes, I can.
Right. So I'll share my screen. I don't have the rights to share. Yeah, now I got it. So I'll share my screen. I have a small presentation. It's just 3 to 4 slides. I promise you, I'll not keep you more on the slides, but I'll take you to the software in just a few minutes. So first of all, I am Vipul Agrawal. I come from Autodesk, and I am the Fusion 360 specialist for India and Asian regions. So any doubts, any questions, you have got a good opportunity right now. You can post it in question and answers or the chat box and let us know the questions. And at the end, we'll take all the questions here. The first thing I would like to start with in the presentation is I wanted to show you this. So this is somehow this is a graphic showing the actual product development cycle which is happening right now in the industries. So you see it's very messy. There are different softwares which are being used in different departments, and then it's even very hectic to find a similar version of file in each of the every department of the same design or of the same manufacturing file which is needed, right? So it's really messy and it's really complicated. Also, if you're working here or if you are in the industry, you might have also faced these things that you cannot find a version or right version of the file, or you have misplaced the files, or the design engineering file which has been sent to manufacturing department now has some missing data. The data is missing in there, or even that the wrong file itself have reached in the manufacturing department. It's not the right file which has been reached. So these kind of problems which are existing in the industry inside the product development cycle. But the solution here is also very simple. Suffice all the departments. So whether it be design department who is actually doing development or the product designing, or the manufacturing department who is doing the tool pathing, the CAM programming, or even the shop floor people who actually just want to view the simulation of the tool path which is needed. Or even since the EVs and electronics boom is going on, your electronics department, you want to devise some chips or devise some PCBs, and you want to check which file is, what is the size of the enclosure which the design department has taken, or what is the space in the design which has been kept. So how do you do all these things? But the solution here is only one, which is the integration. So integration between all these three. And once we get all these three integrations, we can save some time in our product design, product development cycle, and then use that time actually in effective decision making towards the new designs. So a software also, which also does integrate these departments, but also suggest you alternate designs in the same time. So alternate designs in terms of, let's say, reducing mass or increasing the stiffness, or some alternate machining ideas, or some alternate materials which can be used. So these all things are the ideas which the softwares can give you. And finally, connecting you with the departments and the suppliers and the customers. So one, I would say it would be more like an integrated collaborative platform, which will have all these features, right? And the solution to this from Autodesk is Autodesk Fusion 360. So if you say to me, is it a CAD platform, or is it a CAM software, or is it a CAE software, or is it a PCB design software? I would say no, it's not one of these, but it's all of these softwares. Now let's take you to actually the software and show you how things work in here. So this is the software. Let me hide my controls. Yeah. So this is the software we are talking about right now. This is Fusion 360 for you. You can see there is this big design written in here, first things which you might notice. And this is because this is the workspace in which you can design. So I always call Fusion 360 as a platform. The reason being there are several workspaces in this, and it behaves as a platform which can be used for your each and every department. So in this design, we have the solid, surface, mesh, and sheet metal modeling. So you can do any modeling activities right over here. It's very simple. You just can go ahead, create a 2D sketch out of whatever you need. So let's say I create this kind of box, okay, and then create a 3D out of it. As simple as that. Even if I want to create some kind of assembly or some kind of uh, yeah, assembly, I don't need to actually go ahead and create a new file and then go ahead and club it and then create a new assembly. What I can just do is start making my second object from here, taking references from here, and ask it to be a new component. So now I have one body which is this one, and second component which is this one. What I can just do is create this also as a new component. So I'll have my assembly right over here. Okay, these assemblies can also be assembled as per the requirements of the movement. So we do have joints or as built joints that can be used. So let's say if I want this to slide over each other, I can just use this to have a slider joint. Even block constraints, like I can enable the contact sets. I can ask this to be a new contact set. And now when I move these things, okay, oops, just give me a minute. We'll revert the position and just ground this so that this stays at the place. And now you can see it will block it. So this is how you can actually design a complete assembly on this. Right. So this looks simple, right? So we have one actual complete design available for you, which is this. So this is some kind of this is actually not some kind, but a saw which is available. And you can see there is a combination of all kinds of designing techniques done here. So you can see here there is some solid modeling, there's some sheet metal modeling. This whole body which we have created is some freeform modeling which is available, right? And once this is done, what I can do is I can quickly switch this over to my simulation workspace. So what I can do is I have created a different file for just this component. You can see it here like this. And what I really need to do is I can go ahead in the simulation environment and give a stress over here, the actual design input which will be there, and check for the stress. So you can see right now the safety factor is very low. And if I want to see the stresses, there are some huge stresses which are developing here. Right. So in these case scenarios, what I can do is come back into my design environment, Let's say I'll just a second. Why is it? Yeah. Yeah. So now it's okay. Let's say I'll increase the size of this. So by 5 mm. Okay. And now I can be sure that, okay, my product will be working great on this. Okay. And once, okay, I don't know, my mouse is behaving funny today. So just bear with me. Yep. Yeah. So once I'm sure with this, what I can do is I can save this file, and you will look at it right now. As soon as I save this file, my original assembly will start showing me that the file has been updated. then that one component is not the way we wanted. And if you just look here, we'll see the change right now. I'll update it and this will get updated right here. So this is the kind of collaborative working which we are looking into. It may happen that one person is working on one part and another person is working on another part in the same assembly. Okay, what they can do is they can work collaboratively. This is how the person, maybe if my colleague is working on this top, he will get to know, okay, he has updated down, but he doesn't need to change anything. He'll just refresh it and things will automatically change. Right, so this is one collaborative way in which we can work. It is also cloud connected. So you can see here, this is the data panel which we have. Here is where all the files get stored. And if I just open this file and see this people here, I can enter anyone's email ID right here who is using Fusion. And what will happen is this data will be shared with them in their Fusion. And then we can start working collaboratively. Okay, it's again the total words as well. So this is how the basic tools available right away and for the design and simulation. Now coming to the manufacturing, with the same file, what I can do is I can replicate the freeform in my design as a mold, and I can create a setup like this. You can see this is the same setup. It's just coming from design to manufacturing. And in this manufacturing as well, we have all the features and functionalities which might be needed in your manufacturing plant. So we have 2D milling, 3D milling, drilling, multi-axis, 4th-axis, 5-axis available. If you are having a turning machine, then we have a turning option available. If you're working with milling and turning both, you can do turn mill operations with a combination of this. If you want to try additive, if you are doing into metal additive or plastics additive, you can go ahead and do the additive programming. So making things like preparing up the build or checking the orientation of the part, how in which orientation, how much support structures will be needed, or how much infill will be needed. All those things can be done here. If you want to do inspection, on machine inspection, that can be done. And if you want to do fabrication, so basically this is for sheet metal people. If you want to create sheet metal parts or sheet metal nesting, if you want to do water jet plasma cutting or laser cutting applications, then this is where you come in. Once this toolpath has been done, you can also view a simulation, something like this. So this is a milling sample which I have created. Just keep in mind, we do have milling, turning, additive, on machine inspection, and fabrication as well with nesting technologies. So you can get those all things within Fusion itself. With this simulation, again, it's machine accurate. So whatever is going to happen here will same be replicated in the machine. So you can be rest assured that, okay, if any collisions or gougings or anything is happening, that will show it to you here itself. And you know, don't need to figure that out later in the machine. We do have a verification also at the back end going on. You can see here it is almost 86% verified. We don't have any collisions right now. And this is how the tool movements will happen in the machine. Apart from this, the biggest thing of any manufacturing software or any CAM software is their post processors. So as Mr. Womkesh showed us, we have big partnership with all major machine tool guys, and we have a Fusion library of more than 650 plus post processors available inside it. Okay, so even we keep this library updating, and whoever buys Fusion will get all these post processors. They don't need to care about like if this post processor is needed or do I need to pay extra afterwards or anything. So some of the examples are, we have a very good partnership with Haas. So you can see there are a lot of Haas machine post processors available. We do have a partnership with Mazak as well. So there are a lot of Mazak posts available. Then there is obviously Doosan and so on and so forth. If you have Jyoti machines, we have for Jyoti. Okay, or controller specific. So if you don't find your machine post available in this, no need to worry about. We have controller specific. So if you want Fanuc, you can see we have several Fanuc posts available, or Mitsubishi, or maybe Siemens. So you can see the Siemens controller posts are available. So once this is done, you can get the post, or even if you cannot find the post, or if you want to check the post, you can reach out to any one of the Capricorn guys and they will help you. Apart from this, once all these things are done, the CAD CAM CAE part, what you can do is you can invest your time in the innovative thinking. So what does the innovative thinking, when we say the innovative thinking, mean? So let's consider this bracket. Okay, that's a very standard bracket which you will find, or a version of this you will find somewhere around you itself. Okay, so the working of this bracket is very simple. It gets fixed with these 4 points on the wall or in any assembly, and then there is a simple rod which goes around, and then it is used to swivel. So this space in between is actually used to swivel with the shaft which is there in the inside. What I can do is with Fusion 360's generative design, what I can do is I can input this as an input criteria to the generative design. So what we will be doing is, uh, okay, so somehow this got disappeared. Let's see it in this file. So this is the input which we will be giving. Basically what I'm telling it is, with the green geometries, I'm telling it that I don't want this dimension to change, which is actually the whole size of this 4, just because it's gonna fit somewhere and I need a specific size of bolts which are there. And then I have this one, this shaft size as well, which is also fixed. So I don't want it to change the shaft size as well. So that is also I'm telling it by green. And by red geometries, what I'm telling it is, please don't add any material in those places, just because there will be any nuts, screws, shafts which will be going on inside that. Once this is done, I can insert all my loading criterias. So what loads actually are there, which which will be acting on this component. So we have got all the types of loads, or majorly all the types of loads available. I can add the constraints as well, how this is going to be fixed. Okay, my design criteria, like what actually I'm trying to achieve. I want to minimize the mass or maximize the stiffness, or any modal frequencies, buckling or displacement criteria if I have. What will be my manufacturing methods? So let's say if I want to do it by a milling, or I want to try alternate ideas like additive or 2-axis cutting or die casting, I can add these inputs. And materials. So what all types of materials I am okay to use here. So even this is helpful to find alternate material ideas. There is a very big library of materials within Fusion 360, and you can add your materials. It just needs the regular mechanical engineering properties of the material which is there. Once I give all these inputs and give it a few hours to generate the results, I get the results somewhat in this form. So you see, these are several, or maybe, yeah, several of those ideas which can be used actually in the replacement of the original design. I can open this up and see how the design is actually. On the right hand side, you have all the description of the design, like which material it is, what will be the volume, what will be the mass, what is the dimension, and which is there. So you can see on the back end side, it's it will look something like this. Isometric view is something like this. Okay, I do also have a stress view available in which I can see how the stresses will be acting on this. Like once I have the design, I can also compare it with other designs. So let's say if I want to compare it, I can bring two designs side by side just to see what are the different things, because let's say this is having a little bit of higher mass and volume. So I just need to compare and see how things look in both the designs. So that can also be done. Something like this. Okay, and once I'm happy with the design, what I can do is whichever design I like, I can just take it out as a design, as a solid body, or as a mesh outcome, mesh body outcome. Okay, this designs will be totally editable. It's a solid body, so you can edit it with the Fusion 360 designing tools, and then use it again wherever your assembly or wherever the usages are. Apart from this, the last thing I want to show you is Fusion 360 also does have a integrated PCB design or an electronics design module. So if you are into PCB designs, you can see this is how a PCB would look like if you design it in Fusion. This is basically Eagle software which is integrated within Fusion. So you can do a complete design with PCBs, or even you can integrate the ECAD MCAD together. So let's say if I want to bring this in, just give me a second. What I can do is I can go ahead and let's bring this electronic sample. Okay, I need to save this as well. So once this is saved inside my data panel, what I can do is quickly come back, and yeah, this is my air quality sensor. Just give it a few seconds and I can insert it into my current design. So you see, this is how my PCB will look like. I can place it wherever I want to. Just say, let's say somewhere like this. Okay, and once it is placed, even if I need some references or something, I can just start creating sketch on this maybe and start taking the references from the PCB. So I'll use the project command and just want to, yep, project this. I'll project that on the top of my PCB and let it hide. So, and then if I want this to create the structures to actually fit my PCB inside, I can bring this in, join it up, and this is how my PCB will be built. I can just reduce this as well, because this is where somewhere my PCB will fit. So this is how you can use the ECAD MCAD designing, and even your electronics department can work together with the mechanical engineering. By this, what actually you are doing is and make the exact design redesign in the first go itself. And even the electronics and your mechanical engineering departments can integrate each other or collaborative work with each other by just adding each other in the projects folder. It's as simple as that. So this is the whole lot which I wanted to show you in the platform. Still, this is just an upper level view or an upper level explanation of what Fusion 360 is. There are a lot of tools inside it, and I'll request you, if you are interested and if you are looking into more into this, just get in contact with someone in the Capricorn or uh, yeah, actually get in contact with someone in Capricorn and do let us know that uh, you are interested and we can assist you on how this how this will work or how this can be a good fit with company. Yes, so if anybody has any doubts or questions, we can take that up.
Thank you, Vipul. So we'll take up the queries, and this is a very, I mean, the software can be really applied to many industries for almost end-to-end design, engineering, validation, manufacturing activities. So if there are queries or feedback, we are open to it. Please raise your hand and we can unmute you. So any queries or feedback? So we hope it takes more time. It will take more time to understand. Post this session, the moment we log off, there will be a survey available. We'll request everybody to give their feedback. And if you want us to have dedicated sessions or work on your POC project, we would be happy to do it. So we'll provide you support to understand better this software and adopt it further. So kindly give your feedback. It will help us. We have one query. Let me go to it. Try Fusion before buying. Is there an option to try Fusion before buying? So Vipul, you'd like to take that?
Yes, Omkesh. So we are very transparent on this, and yes, there is an option to try. I'll again share my screen here so that you can quickly view. So if you go in Google and type Fusion 360, uh, this Fusion 360, there will be two links. You can just go on the first link here, and there is a free trial download available here. So that trial will be available for 1 month, and it has got all the features and functionalities, and you can just go and register yourself, download, and have that trial available for you.
So I hope we responded to the question. Yes, Fusion and other softwares can be downloaded for a month of free trial. But probably you would also need some support. You could reach out to us. We are happy to support you, but this is an incredibly aggressively priced. Probably you look at the online prices. It is so competitive, and you don't have to invest in high computing powers. Leave it to us. It's on cloud. We have put our server to compute your data and deliver you results. Plus, you can work from anywhere. You can log in globally. Your customers, your principals, they can log in, work on the same platform with all the benefits of engineering, validation, data management, manufacturing. This is indeed, and that's how it's becoming talk of the town. It's built on AI and ML philosophies and very intelligent. We can assure you some good outputs. Second thing, you can work on any kind of data. So if you are using any other software, it need not be that, you have to, you cannot use those data. So if the product is designed in any other software than Autodesk, even through OpenCAD, you can directly import those models and do downstream engineering. So with multiple features. So I'm sure you like it. You can have enough information is available on net uh, and YouTube maybe. But we are always open to support you to explore this tool and use it for your benefits. Thank you very much. We have started receiving some good feedbacks. We kept it a short session because we thought it's productive to have your attention. And almost 100% of the audience attended till end of the session. We really appreciate your interest, and we look forward to further interacting with you. Please don't forget to give your feedback and leave messages. It will help us support you adopt the tool and try it out. Thank you very much. Thank you, Vipul, and everybody.
Thank you everyone for attending. Yep.
Thank you. Have a nice day.
Next day.
Bye-bye.